Okay. Moving on to question 4, this is about how means and standard deviations behave when you add or subtract 5 to a bunch of numbers. So you've recorded the m-5s, you add 5 to each of those, so the mean is going to go up by 5. You don't need to work out the total and stuff, you can, but you don't need to. The mean is just going to go up by 5. That's why it says write down, rather than calculate. So the mean is, and the other really important thing is that the standard deviation is a measure of the spread outness of the data, so it doesn't change when you translate it. When you add or subtract something to all the numbers, you don't change the standard deviation, so sigma equals 0.13. That's the first part. For the mean of all 25 estimates, now you do need to work out the total that everyone guessed. So the first 10 people, so first group, sigma of their masses is equal to 57.4, and the next 15, sorry, that's 10 times the average, next 15, sigma m is equal to 15 times 5.6, which happens, I think, to be 84. So the total mass, so total of all the total guesses, is 57.4 plus 84, I think it is. So the mean is that divided by 25. It's obviously not just the average of the two averages. It's not 5.74 plus 5.6 over 2, because you don't have the same number of people in each group. So the group of 15 people is sort of weighted more in this mean calculation. I think that comes out to 5.65 or something. Let me just double check. That comes to 5.656. Or 5.6623SF. Okay, and this question here, the last part, was done very badly. Fiona's claims that if a group's estimates are more consistent, they are more likely to be accurate. Given that the true mass is 5.65, comment on this claim. So this claim is about comparing two groups and saying that if this group's estimates are more consistent, they are more likely to be accurate. We have two groups here, folks, a group of 10 people and a group of 15 people. This question has got nothing, and I mean nothing, to do with this number, with the average of all 25. It's to do with comparing the estimates made by the first group and the second group, because Fiona's claim is about different types of group, consistent ones and accurate ones. The first group has a smaller standard deviation, 1.3 rather than 1.9, so it's more consistent. So first group more consistent. The second group is actually more accurate. The second group is only out by 50 grams, whereas this first group is out by 140 grams in terms of that average. So the second group is more accurate. So Fiona's claim is wrong. That's it. Okay? It's about two groups, and it's got this word given, so you've got to use the data in this question. You're making general claims about how accuracy and consistency aren't related isn't going to get you both marks here. No way. Okay, so I hope that makes some sense. And that was the end of question 4.